All right, and we are live. So, good morning, good afternoon, and good evening to our viewers from around the world. Thank you so much for joining this live webinar hosted by AppSecEngineer. My name is Anish, and I'm joined by our DevSecOps lead, Vishnu Prasad. Hi, Vishnu.
Hi,
So, I'm
Anish.
sure. Hi. So I'm sure all of you will be familiar with Vishnu if you have attended any of our live sessions because he's one of our most familiar faces over here. So you can expect an excellent and really scintillating session ahead of us. So before we get started, I just want to inform you guys that this webinar will actually be just a small taste of what you can expect from our full 4-day bootcamp hosted live by our instructors at AppSecEngineer. We have 6 different boot camps covering topics like threat modeling, DevSecOps, AI security, secure code review, cloud native security, and supply chain security. So I'll give you the full details of all this exciting stuff coming up in our live boot camps at the end of this webinar. So stay tuned. And trust me, you don't want to miss this. Now, let's get back to the webinar. So Vishnu, I hear this our live session today is about DevSecOps and something related to source composition analysis. So can you tell me more about that?
Sure. Yeah. Today we're going to discuss some overview about DevSecOps, a bird's eye view of DevSecOps. And source composition analysis is a part of supply chain measures or the supply chain analysis action items that is a major part of DevSecOps. So it's comprised of all the third-party dependencies that we're going to handle in our application, how to secure them, how to analyze the findings that are present in those third-party dependencies is the complete discussion that we're going to do today. As part of this, we're going to start with some introductions of how the DevSecOps has been implemented, a quick overview of kind of thing. Post that, we're going to deep dive into the key features of SCA, what are the attack vectors of SCA, and what are the targets that attack SCA is going to focus on to start scanning with. Post that, we're going to analyze a file known as SBOM. We're going to generate a bill of material for all the third-party dependencies present in our application, and we're going to analyze it with one of the tools known as OWASP Dependency-Track. And post that, we're going to discuss some of the framework standards, specifically two framework standards known as CSAF and VEX, and what are the use cases of those two standards and frameworks. And we're going to see how to generate those files as well with the tool that helps us to do so. So with that note, can I get started with?
Sounds great. Let's
Sure.
go.
Thank you. So I'll just share my screen and I'll just start with today's discussion. So here you go. So welcome everyone for this quick webinar of DevSecOps Masterclass with source composition analysis. My name is Vishnu Prasad. I'm a DevSecOps lead at AppSecEngineer. I do consulting, automation, and training related to DevSecOps, cloud security, container security, Kubernetes security, and LLM security as well. Apart from that, I'm a Black Hat trainer, DEFCON, OWASP trainer. I do a lot of trainings in conferences across the globe. I do something related to research on LLM security precisely in the current times. So this is a quick introduction about myself. With that note, we're going to get started with today's discussion. We're going to see the bird's eye view of DevSecOps now. So implementing the security measures in each and every phase of your SDLC in your software development lifecycle is known as a DevSecOps implementation. The main objective of implementing these scans or these security measures in each phase of the software development lifecycle is to achieve the shift left approach. I mean, as much early as possible, we're going to find and we're going to detect the vulnerabilities present in your source code or in your third party dependencies or in your containers or in your Kubernetes configurations or in your cloud deployments. As much as possible, we're going to detect it early and we're going to fix and we're going to patch it early. So this is the primary objective of any sort of DevSecOps implementation. So this is one of the measures. I mean, this is one of the flavors of setting up the DevSecOps pipeline. So in this DevSecOps, there is a major segment known as software composition analysis, or also known as source composition analysis as well. In this, we're going to primarily target on third-party dependencies that we have procured from external sources. So when you're developing your application, you're going to write source code, right? Apart from that, you're going to leverage some of the third-party dependencies from external sources. It might be from PIP, it might be from NPM or Maven as such. So the vulnerabilities present in these third-party dependencies are our primary focus when it comes to SCA. This is done during the build time. So because the packages are ready and the libraries are packaged during the build time, right? So these scans are performed during the build time of your complete SDLC lifecycle. So whenever we get the findings in this SCA or the software composition analysis, we're going to get the vulnerabilities in CVE format, where we're going to see a lot of CVE numbers associated to the vulnerabilities that we're going to find in third-party dependencies with. And also we can see some of the license risks, outdated packages, some of the outdated versions that are already accumulated in your package registries. All these aspects in your application environment can be focused when it comes to software composition analysis. So the focus areas are always about the third-party dependencies, open source libraries, licenses, and also the transitive dependencies. For example, you have your primary dependency in your POM or your requirement.txt file. Once you install it, lot of other third-party dependencies which are supporting to the primary dependency will also be installed. So those dependencies are known as transitive dependencies, which are dependent on the primary dependencies. So if there is a vulnerability in a primary dependency or in a transitive dependency, it goes hand in hand. I mean, the vulnerability will be present across the complete package or the complete binary by itself. So this would be our focus area when it comes to SCA. And when it comes to the targets, we're going to focus on a lot of package registries like npm for Node, Maven for Java, pip for Python, and some of the package.json files, pom.xml files, requirement.txt files present in your applications. So we're going to generate some bill of materials files for these type of package registry files present in your application, and we're going to analyze those bill of material files. I mean, the SBOM files that we have generated for will be analyzed with some of the framework standards. So this would be the further discussion that we're going to deal with today's webinar with. And we're going to as part of the SCA is concerned, we can also scan containers as well, but this is not included in today's session, but it's an extended version of SCA. You can focus on it, and you can have as it as a further reading kind of approach. So the main database that is used while we are performing the scans are known as NVD database, that is National Vulnerability Database. So this database is having a lot of CVs associated to a lot of vulnerabilities that are present in third-party dependencies. So once you start scanning your SBOM files, the tools will actually fetch the information from NVD database, and this NVD database will publish all sort of CVs associated to vulnerabilities, and also more information associated to that particular vulnerability and how to fix those vulnerability, which is the patched version of that vulnerability, etc. So apart from that, we're going to see what is an SBOM is all about. So SBOM is also known as software bill of material, which is a standard format or the representational format of all the third-party dependencies present in your application source code. So if you're referring to a pom.xml or requirement.txt file, so all the third-party dependencies which are present in those package registry files or the package manager files will be listed in the structured format, uh, generally in an XML format known as SBOM or a software bill of material. So each SBOM will have a lot of information such as the dependency name, the license of the dependency, who is the provider of that particular dependency or a library, and what is the version of that you have installed in your application environment, and what are the patches and updates that are been present in that particular SBOM file. So please remember, SBOM is not a vulnerability report or a vulnerability scanning report of your third-party dependencies. It is just a representational format of all your third-party dependencies with all this information, which will be a feed, or which will be an input for your tools to perform SCA or software composition analysis, where it's going to find all the vulnerabilities all about. So apart from that, we have some framework standards known as CSAF. It's also known as Common Security Advisory Framework. So this is one of the frameworks that has been prescribed by Organization of Advance of Structured and Information Standards. So this is an organization which will publish this information along with the CV information. So these organizations are known as vendors. So when they publish a CV information into a database, so these CV information will be associated with this CSAF format as well. So this CSAF format or a file which will help us to get all the advisories that is required to fix that particular CV or fix that particular vulnerability present in the third party dependency with. So this is a standard format which will help us to achieve the remediation faster, which will help us to automate the remediation faster when it comes to fixing and remediation of the third-party dependencies which are subjected to vulnerabilities. As the word itself says, it is common security advisory framework, which will have all the set of advisory steps that can be taken to that particular CVE so that that CVE will get remediated with. So SBOM will give all the information that is present in your package registries, I mean, in your package manager. CSAF will give the advisory information that is required to fix the vulnerable packages that are present in your application environment, right? So we have one more standard known as VEX, Vulnerability Exploitability Exchange. So this is another format that is given by the vendors again for the CVE information. So the CVEs will be associated with this VEX data as well, where it's going to actually specify whether this particular CV is exploitable or not. So long story short, SBOM gives what's inside your application package managers, and VEX will give what actually is exploitable in your application package managers. So VEX will give the list of all the third-party dependencies in your application. SBOM will give all the third-party dependencies in your application. VEX will give actually what are the dependencies that are actually exploitable in your application with. So by this, we can achieve like a high fidelity feedback loop by decreasing the false positives in your findings and by increasing the true positives. So this exploitability will actually give the true findings, and it will give the reason, or it will give the justification why it is actually exploitable, or it gives the justification by saying why the particular third party dependency is not actually exploitable with. So this is how the VEX and CSAF formats will help us to achieve further analysis with your SBOM, and what are the action items that we can take once we perform the scans with our SBOM with. So with that note, we'll get started with our first lab session or the hands-on session where we're going to generate an SBOM file and we're going to analyze that SBOM file with dependency track. So with that note, I have provisioned the lab instance previously to save some time. So this is the lab environment or the lab platform where we can execute all the hands-on labs. So in the bootcamp as well, we're going to execute all the hands-on labs using this same platform. So each hands-on lab will be having a deep documentation, how to interact with that lab session, how to go and perform, how to simulate the steps that are present in the hands-on session of this lab. So at first, I'm going to click on this OWASP dependency track. So this is a tool which has been open sourced by OWASP Corporation by itself. So which will analyze the third party dependency artifacted SBOM file, and it will give a lot of vulnerabilities associated to it with the help of NVD database, and it's going to give the severity as well. So at first we can run this docker run command, which is a Docker variant of this particular tool, which will be running a console with the scanner as well in the port 8880. So to make it quick, I've already run this lab here. Let me reconnect it. All right, the
So
session has
this
been
lab will
terminated.
be, so sorry, will this lab be one of the labs we'll be doing in the bootcamp as well?
Yes, definitely. So this is added in the curriculum or in the syllabus of the bootcamp. So I just added it to the webinar.
Awesome.
So yeah, let me reprovision the box. I mean, that was been timed out. Yeah. So once you click on this, there will be a start lab button here. So once you click on the start lab, there will be a progress bar happening to provision a dedicated sandbox environment for yourself. So this is completely boxed with all the dependencies that are pre-installed. You don't need to install any of the dependencies to run this lab. You don't need to bring up any sort of binaries in your local host machine to start this lab. This environment itself, this portal itself suffice of all the dependencies pre-installed. It's going to give you a sandbox with a beautiful IDE where you can execute all the terminal commands, execute the application, simulation, everything. It's pretty hands-on. So yeah, once there is the complete progress has been done, there would be two options. One, to end the lab once you're done with executing the complete lab, and there is an access lab button as well. So when I click this access lab button, there would be a new tab in the browser that would be loading your complete the ID to run this tool. So at first, I'm going to run this Docker command. I've run this Docker command, which is bringing up the dependency track application on port 8880. So which acts like both a console and also a scanner where it's going to scan the dependencies and flag the vulnerabilities as well. So it's running on port 8880. Let us give 45 seconds so that all the services internally are getting up and running. So it has multiple services internally. There is an NVD database. There is a small parsers and serializers internally. So it takes some time to bring up all the services up and running. So in the meantime, I'll just take a new terminal and start generating the SBOM file for a intentional vulnerable um, application. So there is an intentional vulnerable application pre-artifacted in this lab instance known as cut the funds. So this is a intentional vulnerable application built in-house by our organization, which is having all the outdated libraries purposefully placed for us to scan in this uh, hands-on session. So I'm going to first build this application with npm install. So once this application is built, we're going to analyze this. We're going to generate an SBOM file with the help of tool known as CycloneDX. So CycloneDX is one of the famous tools which is having both a platform dependent and a platform agnostic variant of tools, where you can actually download a CycloneDX to generate SBOM file for only Node tech stack, only Python tech stack or Java tech stack. Or there is a platform agnostic version as well, where the CycloneDX can literally generate SBOM files for all the tech stacks like Node, Python, Java, etc. So in this example, I'm using a Node variant CycloneDX tool, which is used to perform generating of SBOM files here. So I'm going to install this CycloneDX Node variant CycloneDX tool with the help of npm install -g CycloneDX command. So now that all the dependencies are built, you can see there are a lot of vulnerabilities report given by npm audit. So now I'm going to install this CycloneDX uh, tool as well. So once the CycloneDX tool has been installed, we can generate a BOM file for package.json. So in the same directory where we have package log.json, we're going to execute this package log.json. We're going to execute this command so that it's going to read all the packages present in this package log.json, and it's going to convert into a SBOM format so that we can further analyze for vulnerabilities. So once we do this, so there would be a bomb.xml file generated with XML format here. So you can see there is a lot of license information, there is component information, all this. So this is not readable, or this is not human readable friendly. So this is machine readable. So we're going to upload this file to a dependency track uh, application, and we're going to analyze this. So now that the dependency track is up and running, we're going to access this dependency track in a browser now. So we can go to this URL with an IP. And once we click on continue, it's going to load the console of dependency track. So this is a login page of dependency track here. So by default, the credentials would be admin. So it asks to reset the credentials at first. So I'm going to reset the credentials to something unique. So once the reset of credentials is done, it's going to ask again to login. So once I log in, there would be a dashboard kind of platform or a UI that would be appearing. So in this, we're going to create a project to upload our SBOM file with. So for that, I'm going to create a project saying, yeah, bootcamp demo CTF. So I'm going to name this version of my choice as 1.0. So in this classifier, I'm going to select as application because we have generated an SBOM file for applications. So we have a lot of options to take here. If you have generated for a machine learning algorithm, we can select machine learning model. So if you have generated an SBOM for containers with the help of Swift, tool called Swift, you can select containers so that the remediations and the descriptions for that vulnerabilities would be way more precise and in-depth. So I'm selecting application because I have generated an SBOM file for application here. So I'm going to give a small description saying demo application. You can give any description of your choice and you can start creating the project. So once the project is created, you can click on this project. You can go to the component section here, and there's an option to upload the BOM that you have generated for this application. So we can go to a lab instance again, and we can just click on this BOM.xml file, and we can download this. So that would be downloaded into your local machine. So then you can go here and click on upload BOM option. You can just drag and drop this BOM.xml file, and you can upload this. After a few seconds of parsing, internal parsing, and contacting with the NVD database, it's going to list out and it's going to map all the CVs associated to each packages here. So if you refresh the screen after a few seconds, uh, you can see this. There are a lot of findings that are already listed with. There are around 7 critical, 18 high, 10 medium, and 0 low, and 12 unsigned vulnerabilities. So you can see all the list here. So you can go with the pagination option to just check with all the packages that are being listed out with vulnerabilities. So if you click on any of the package, for example, if we take this Bison, so it's going to list out the vulnerabilities present in this. There are two vulnerabilities, one is medium, one is critical, and the vulnerabilities associated by the CVE names, right? Common vulnerabilities and exposures is the full form of CVE, where the vulnerability, when it was first research, or when it was first found, will be flagged by the year number at first and followed by a unique name that would be associated to that particular vulnerability. So if you can click on this, you can get a lot of other informations like overview, weaknesses, and some references as well to fix this particular vulnerability. So this is how the OWASP dependency track will help us to analyze our SBOM files that are generated by CycloneDX. So next, we're going to generate a VEX and CSAF format for our um, SBOM that has been generated. Again, I'm going to generate an SBOM with the help of a tool known as Depscan. So Depscan is a tool that is used to generate VEX and CSAF format. Again, it will internally use a clone of a CV database. So it uses a clone of CV database with all the information like VEX and CSAF format data that has been provisioned by vendors. And every time you clone this tool, every time you reinstall this tool, a latest version of the database will be cloned into your host machines or your local machines where the actual scanning is taking place. Right. For this, we need to switch to this next lab segment or the lab uh, option here, known as OWASP Dependency Scan with SBOM, CSAF, and VEX. So yeah, this is a depth scan. We have a lot of information why we need to use and some basic theoretical information present in this documentation. Post that, we are going to have actual steps to simulate this. So at first we can activate the virtual environment in which I have installed the tool by default. And this step would make sure that the latest version of the NVD database or CV database has been cloned and it has been patched to the latest version with all the VEX and CSAF information that has been provisioned by the vendors in the latest manner. Right. Now I'm going to clone the cut the funds application, the same application that you scanned with in a previous example here. So I'm going to take this cut the funds application, clone it, and now I'm going to go to this directory where we have all the vulnerable third-party dependencies. The same source code that we did in dependency track, we just generated an SBOM and analyzed an SBOM. But in this example, we're going to generate VEX and CSAF format files for this SBOM for further analysis to achieve the high fidelity feedback loop and also to achieve it uh, actually to have the remediation steps precisely. Actually, to have the remediations precisely. So I'm going to run this depth scan on this particular code base. So it's going to start the depth scan and it's going to generate the reports in the same code base. So there would be a folder by name reports generated. It will take few seconds to generate the report. You can see this, there is a report folder generated with SBOM universal.json. In this example, it has generated an SBOM file in the JSON format. So in the first example, we did it with XML format here. So this has listed all the third-party dependencies in the JSON format here. So next, what we're going to do is there is one more feature with this tool known as reachability analysis. So before the SBOM completely gets generated, I'm going to explain what is reachability analysis is all about. So think about your application is having a lot of other tech stacks, uh, dependencies as well, artifacted in the same repo directory. There is dependencies with Java, there's dependencies with Python and other tech stacks as well. If you want to primarily focus on only one particular tech stack, like if you want to scan only the JavaScript related the dependencies, you can add saying research -t with JavaScript, which is known as reachability analysis, which is going to primarily focus on all the dependencies that are related to JavaScript. So we can do that as well with the help of this Depscan, right? So you can see the results as well. There is a depscan scan results as well. Apart from SBOM, it's going to scan the SBOM and it's going to give the CVs as well. So now we're going to run reachability analysis for the same source code, only for the JavaScript files. Suppose that we're going to generate a CSAF format, that is Common Security Advisory Framework format report. In that, even the VEX would be added up. Even CSAF and VEX would come hand in hand in a single report, and it's going to be artifacted in the same reports directory. We need to run this twice. I've added the comment saying we need to run this twice because once it's for the artifacting of the toml file to generate CSAF, and the second time to actually generate the CSAF and VEX format files. So you can see only the dependencies that are associated to JavaScript. You can see this, all the findings has been listed by filtering the dependencies in the entire code base that are related to only JavaScript. So this is one more salient feature of this dependency scan tool here. And at last, now we're going to generate a CSAF and VEX format tools here. The CSAF and VEX format framework report here. So the first time it's going to generate, yeah, the CSAF toml file, which is an intermediate domain specific file to generate CSAF and VEX report. The next time you generate this, you run this command again, it's going to generate a actual file for you.
So I'd imagine that these would be really useful to, like add into your SDLC, right? Like as you are going through the different steps of your security program, these
Yeah,
sorts of scans and processes can be slowly added into your security program to kind of bolster your the scanning process and all of that. Because I mean, when we're talking about something like shift security left, I think this would be
yeah.
one of the most important components of that.
Yeah, actually, to once we get this report, it would be very hectic for the developers to start fixing actually. So this type of intermediate reports like VEX and CSA format, which would be having the default remediations that is required for fixing those vulnerabilities, and also the actual true positives as well, whether that particular finding is exploitable or not. For example, you have found insecure deserialization with on a third party dependency level, but you have hardened your sandbox with a lot of restrictions at the runtime itself. So that would be a extra layer of defense that you have taken care at the application runtime level itself. So you can ignore that. You can add a comment saying this has been taken care, this blast radius has been taken care in another environment or in another perspective, so that you can ignore that particular findings as such, and you can give a reasoning for that. So I mean, this CSAF and we will have a lot of other information related to these type of action items.
Awesome.
Yeah. So yeah, you can see this. There is a CSAF V1 version that is being generated with a lot of information. You can see this. There is a one vendor published VSAF or the VEX, CSAF and VEX format. There is a vendor published CSAF and VEX format with all the categories, so legal disclaimers, and also with full product names, and also a lot of information saying vulnerability descriptions. So it gives a text saying denial of services has been happening with this particular version, so that you need, by passing this carefully, you can do this, remediate this. So all this information, there'll be some recommendations as well given to upgrade to which version that is required with, as it the framework itself says common security advisory framework. So it's going to give the scoring as well for each finding. So it's going to acknowledge with the findings as well, but with the help of NVD database. As I said, it's a backbone of all the source composition analysis or software composition analysis scans with. So yeah, this was my quick discussion for today of generating the CSAF and VEX format files and analyzing the SBOM files. So yeah, over to you, Anish. Let me know if you need any uh, questions
Thanks
to
so
be
much,
discussed.
Vishnu. This was a really interesting session, and I'm really hoping our viewers learned a lot, because this is just the start. This is a small taste of what you can
Yeah,
actually expect in our boot camps. And like I
yeah,
mentioned, I have something very special for you, for all of you who stuck around to the end of this webinar, because when you sign up for these boot camps, these are going to be live sessions with the instructor. So Vishnu will be taking one of the classes, but we have 5 others by our expert AppSec engineer instructors. So when you sign up for these boot camps, not only can you attend the live class, but you can also access the recorded content for up to 1 year after the purchase, along with getting 1 full year of access to the AppSec Engineer Pro Plus subscription, which means that you get all the courses, all the labs, and all the challenges on our platform. And also, you'll also be able to take our certification exam in the relevant AppSec engineer certification. So in this case, it would be the DevSecOps certification, but there are other certifications as well. And you'll need to take within 1 year of attending our bootcamp. And with that, you'll officially be a certified application security professional with hands-on skills in real-world problem solving and security knowledge. So I just wanted to announce one little gift for all of you guys who stuck around to the end. We're giving away a 10% discount code for all people who attended this webinar. So you can just use the code Vishnu10 to get 10% off your purchase of the certified DevSecOps Engineer Bootcamp hosted by Vishnu Prasad. And this is a limited time offer, so please avail of it as soon as you can and grab your seat soon. All right. So we'll include the links down below where you can get more details, and you can go to our website, appsecEngineer.com, to get all of the information. But let me just say that this is one of the most incredible learning opportunities available anywhere in the security industry, and I can't wait for you to experience it. Thank you so much, Vishnu, for taking this live session with us. And I hope to see all of our viewers in our boot camps very soon. See you then.
see you, Anish. Thank you.